Hello everybody, hope all of you are fine. Today I came in front of you with another topic called as chemical equations and reactions, which is important in 10th class as well as 11th and 12th classes also. Now let us enter into our topic, that is we have to balance a chemical equation. Why we need to balance a chemical equation? Because we have to balance a chemical equation because whatever mass it is there before the reaction, same mass should be there after the reaction also. That means what? Mass of the substances cannot be created or it cannot be destroyed. So this is called as law of conservation of mass. What is law of conservation of mass? Mass can neither be created or nor be destroyed. So whatever mass it is there before the reaction should be same after the reaction also. So whenever we write a chemical equation like this, the mass, total mass before the reaction and the total mass after the reaction will not be same. So it should be balanced. That means what? How many number of sodium atoms or oxygen atoms? In this example, whatever different elements or atoms we have before the reaction should be same after the reaction also. For example, here we have sodium 1 atom, but here sodium 2 atoms. Oxygen 2 atoms, oxygen 1 atom. So that what happens? Total mass before the reaction, total mass after the reaction will be different because number of atoms are different. So we have to balance it to have same mass before the reaction and after the reaction also. How do we follow? What process we have to follow? Balance the chemical equation. Let us see some examples today. First example is sodium plus oxygen gives rise to sodium oxide. So here if you observe, let us when you follow this procedure, what we do? First you write all the atoms involved in the reaction. That is what sodium we have. Sodium is one atom and oxygen is one more atom. This is a simple example. Reactant side and product side we have to write like this and table it. Sodiums, how many are there reactant side? One is there. After the reaction, product side we have two sodiums. So here reactants, how many are there? Oxygens. Oxygen reactant side two we have, but product side there is only one oxygen. If you observe, sodiums are different and oxygens are also different before the reaction and after the reaction. Now, because sodium atoms two we have in the products, reactant side also we have two sodium atoms. So what we do here in the next step, I am writing it as two sodiums, 2Na plus O2 gives rise to Na2O. Now after this step, if you observe what happens, sodiums and oxygens again you list out uh, reactant side and product side. Reactant side, how many sodiums we have now? Two sodiums. Product side also two sodiums. But oxygens, if you observe, here how many oxygens we have? Two oxygens we have. But product side we have only one oxygen. Means what? We balance the sodium atoms, but oxygens are not balanced. Now we need to balance oxygens. So to balance oxygens, what? Here only one oxygen we have. So we have to multiply 2 here so that we get 2 oxygen. So in the next step, what? Our equation becomes like this. 2Na plus O2 gives rise to 2Na2O. Okay. Now what happens? Again sodiums and oxygens you take reactant side and product side. Reactant side, how many sodiums we have? 2. Product side 4. Now again when we balance oxygens, sodiums are unbalanced. So let us complete this. Now oxygens here 2, here also 2. Oxygens are balanced but sodiums are different. So again to balance sodium, what you have to do? These 2 we can make it 4. Instead of 2 we can write it as 4. Now what happens? 4Na plus O2 gives rise to 2Na2O. Now if you observe how many sodiums we have and how many oxygens you have, reactant side and product side, once you observe, reactant side we have 4 sodiums, so 4. Product side also 2Na2 means what? 4 sodiums. Okay, and oxygens also reactant side we have 2, Product side also we have 2. So sodium atoms are balanced. Sodium atoms are balanced and oxygen atoms are also balanced. So this is what final balanced chemical equation of given equation. This is what balanced chemical equations of the given thing. Hope you understood this. We will discuss one more example to understand more better. Next example, and this is another example, Mg plus O2 MgO. This is also a very simple example. Within one step we get it. So here also we follow first what are the atoms we have, different atoms we have. We have magnesium and oxygen. Magnesium we have in these different atoms, oxygen we have. Reactant side and product side we have to check. Reactant side, how many magnesium we have? 1. Product side, how many magnesiums we have? 1 only. But reactant side, how many oxygens are there? 2. Product side only 1. So magnesiums are already balanced, but oxygens are not balanced. So what we have to balance? Oxygens we have to balance. So for that, what we need to do? Mg plus Mg plus O2 gives rise to, we have to write 2MgO. 2MgO. So that what happens? Magnesium side, magnesium reactant side 1 only, but 1 second. So magnesium, oxygen, reactant side, product side. So magnesium reactant side only 1, but product side 2. Oxygen reactant side 2, product side also 2. Now oxygens are balanced, but magnesiums are not balanced again. So what magnesiums we have to balance? Because you have 2 Mg here, here also you have to write 2 Mg. Then the final equation will become like this: 2 Mg plus O2 gives rise to 2 MgO. This is what balanced equation. If you see Mg and oxygen, magnesium and oxygen on reactant side and product side, what we have here, magnesiums 2, there also magnesiums 2. Here oxygens 2, here also oxygens 2. So magnesiums are balanced, oxygens are balanced. So this is what final balanced equation of given equation. Hope you understood this also. It is. Now let us see this equation. We have nitrogen and hydrogen, here ammonia. So here, is it balanced? Here 2 nitrogens are there, here 1 nitrogen is there. Here 2 hydrogen is there, here 3 hydrogens are there. So it is not balanced. So let us see how many nitrogens on reactant side and how many hydrogens. Reactant side and product side. How many nitrogens we have reactant side? 2, and product side 1. Similarly, hydrogens here reactant side 2, hydrogens on product side 3. So better we will balance nitrogens first. Here 2 we have, here only 1 we have. So we multiply 2 here so that we get nitrogens will be balanced. N2 plus H2 gives rise to 2NH3. Now check it. Nitrogens, hydrogens. Reactant side, product side. So nitrogens we have reactant side 2, product side also 2. Hydrogens we have reactant side 2, but here product side 2 into 3, we have to multiply this. 2 into 3, 6 hydrogens we have on product side. So nitrogens are balanced, but hydrogens are not balanced. We have to balance hydrogens. Here 6 hydrogens we have, here 2 hydrogens we have. To get 6 hydrogens, what we have to do? We have to write 3 here so that hydrogens will be balanced. So what is our final equation? N2 plus H2 is there, but we have to write here 3H2 gives rise to 2NH3. Now once you check nitrogens, hydrogens, reactant side, product side. Nitrogens we have 2 here, there also 2. Hydrogens we have 6 here, there also 6. So nitrogens are balanced, hydrogens are balanced. So our balanced equation is 2NH2, N2 plus 3H2 gives rise to 2NH. That is the balanced equation of given equation. Now let us see one more example. This is another simple example. Here we have sodium. Let us write what are the atoms we have: sodium and chlorine. Reactant side, product side. Reactant side we have only one sodium. Product side also we have one sodium only. Sodiums are already balanced. But chlorines reactant side we have two, but product side only one. So to get two chlorines, what we have to do here? Two we have to write. So our equation becomes Na plus Cl2 gives rise to 2NaCl to get two chlorines on product side. Now if you check sodium, chlorine, what we have here? Reactant side, product side. Reactant side we have one chlorine, one sodium, but product side we have two sodiums. Chlorines are balanced, 2, 2. Now chlorines are balanced, but sodiums are not balanced. To balance sodiums, what you have to do again? These two should be multiplied reactant side also. Now our final equation becomes 2Na plus Cl2 gives rise to 2NaCl. Now once check sodiums, chlorines. Sodiums, how many we have reactant side? How many we have product side? Reactant side we have two, product side also we have two. Chlorines also reactant side we have two, product side also two. So sodiums are balanced, chlorines are balanced. So our balanced chemical equation of this equation is is 2Na plus Cl2 gives rise to 2NaCl. Hope you understood this. Now the next question. Next equation is CH4 plus O2 gives rise to CO2 plus H2. Okay, it is methane. Methane plus oxygen gives rise to carbon dioxide plus water. So here, how many are there? We have different atoms, carbon, different atoms we have here, carbon, hydrogen, oxygen. We have three. How many we have reactant side, how many we have product side, we have to find. Reactant side, how many carbons are there? Only one carbon. Product side, how many we have? Only one carbon. Carbon atoms are already balanced. Hydrogen atoms, reactant side we have four, but product side we have only two. Oxygen atoms we have reactant side two, product side here two and here one. Two plus one, three are there. So hydrogen and oxygen are not balanced. So first we will balance hydrogen on both the sides. To get hydrogen's balance, what we do here, 4 are there, here 2 are there. We have to multiply 2 here. Then we get equation as CH4 plus O2 gives rise to CO2 plus 2H2O. Now again if you write all this, carbon, hydrogen, oxygen, reactant side, product side. How many carbons? Here one, here also one. Carbons are already balanced. Hydrogens, how many are there? Here four, here also four. Hydrogens are also balanced. But oxygens here two. Here how many now? Here two are there, here two are there. Total four are there. So here this side two, this side four. So oxygens are not balanced. Carbons are balanced. Okay, hydrogens are balanced, but oxygens are not balanced. To balance oxygen, what? Here already four are there. Here if we write two, then oxygens also they will be balanced. So what is the final balanced equation? CH4 plus 2O2 gives rise to CO2 plus 2H2O. This is what balanced equation. If you observe carbons, hydrogens and oxygens, reactant side, product side. How many carbons we have on both the sides? 1, 1. How many hydrogens we have on both the sides? Here 4. Here also 2 into 2, 4. 4, 4. How many oxygens we have on both the sides? Here 4. There also 4. So what? Balanced. This is what? The balanced equation of the given equation. Now, one more. Hope you are getting idea how to balance it after you are seeing all these examples. So this is one. This is one more. Let us see here. In this we have lithium and hydrogen and oxygen. Lithium plus water gives rise to lithium hydroxide plus hydrogen. So here let us list out what all we have. Lithium, hydrogen, oxygen. Reactant side, product side. Reactant side we have one lithium, product side also we have one lithium only. Reactant side we have two hydrogens, product side also we have two hydrogens. Okay. Reactant side we have one oxygen, product side also we have one oxygen only. So all are balanced. Lithium is balanced, hydrogens are balanced, oxygens are also, hydrogens are not balanced. Sorry. Here hydrogens we have three, not product side we have here one, here two. So three hydrogens are there. So we have to balance hydrogens here. To balance hydrogens, what we can follow? Lithium is already same. We can write here 2LiOH here. So what it is? Li plus H2O gives rise to what happens here? 2LiOH plus H2. So here what is happening? Li is changing. So here only one reactant side, product side, reactant side and product side. Reactant side we have only one, but product side we have two. And hydrogens. Hydrogens we have two here, but that side 2 plus 2, 4. Oxygen here we have only one. Oxygens how many we have reactant side? Only one. Product side 2. Now we want two lithiums, 4 hydrogens. See exactly 2 times we have. Exactly here 2 times we have. So better you multiply these two by 2 so that will be balanced. So how we can write it? Final equation 2Li plus 2H2O gives rise to 2LiOH plus H2. Now if we observe lithium, hydrogen and oxygen on both the sides, reactant side and product side, how many lithiums we have on both the sides? 2, 2. How many hydrogens we have on both the sides? Here 4, here also 2H, here 2H. So here 4, here also 4. And how many oxygens are there? Here 2 oxygens are there, here also 2 oxygens are there. So all the 3 types of atoms are balanced on both the sides. So that is what one more balanced equation. Hope you understood how to write these balanced chemical equations. Right, let us see one more now. This is NaOH plus H2CO3. This see no slowly a little we are doing complicated, difficult questions. Not very difficult, but comparatively starting, these are some difficult. So here what all we have? Different atoms. Sodium we have, hydrogen we have here also, oxygen we have, carbon we have. 4 types of atoms are there on both the sides. Reactant side and product side. Reactant side, how many sodiums are there? Only one. Product side, how many we have? 2. Then hydrogens reactant side here 1, here 2. Total 3. But here only 2. Here only 2. Next oxygens here we have 1, here 3. 1 plus 3, 4. Here how many we have? 3 plus 1, 4. Oxygens are already balanced. So carbons here 1. Here also 1. Carbons also we have same 1, 1. So what it should be balanced? Sodiums and hydrogen should be balanced. So for that what we need to do? We need to balance this NaOH. NaOH, I will write it as 2, 2 times NaOH. So what happens? Let us see. 2 NaOH plus H2CO3 gives rise to Na2CO3 plus H2O. And let us check again on both the sides. Sodiums, hydrogens, hydrogens, oxygens and carbons. Sodiums we have here 2, there are also 2. So sodiums are already balanced. Next what we have? Hydrogens. Here 2 hydrogens, 2 into H, 2 hydrogens, here also 2 hydrogens. So how many hydrogens here? 4 this side, but here only 2 hydrogens are there. Hydrogens are not balanced still. Next oxygens. Here we have 2, here we have 3. Here we have 2, here we have 3. 2 plus 3, 5 oxygens here. Here how many we have? 3 plus 1, 4 oxygens here. Oxygens are also not balanced. Now coming to next carbons, there is no change in carbons. Here 1, here also 1. So we need to balance hydrogens and oxygens. So for that what we do here? Here we write, we have less here, this side we have less. So we write here 2H2O. If you write 2H2O, what happens? 2NaOH plus H2CO3 gives rise to Na2CO3 Na2CO3 plus 2H2O. If we write like this, what it is happening? Sodiums are balanced 2, 2. Next, hydrogens are here 2 we have. 2 plus 2, 4 here. There also 2 into 2, 4 we have. Next, oxygens. Oxygens, if you observe, what we have oxygens here? 2 plus 3, 5 we have. But there 4, 3 plus 2, here also 5 we have. Here 3, 2 oxygens here, 5. Oxygens are also balanced. Now what last we have? Carbons. Here 1, there is also 1. So carbons are also balanced. You can check it. All the different atoms are balanced. So that is what final balanced chemical equation of given equation. So that is what the balanced equation. Every time you have to check one atom by another atom. You have to balance it. You will get it last. This is what final example I am going to explain to you. By this I hope you got how to balance the chemical equations. Now let us see this one. We have irons and sulfur and oxygen. 3 types of atoms are there. So here reactant side and product side. How many we have reactant side irons? Only 1. But product side we have 2. 1. Now coming to sulfurs, here we have 2, but here we have 1. 2, 1. Oxygens here how many we have? Only 2. On that side 3 plus 2, 5 we have. Okay. Like this way. First we will balance irons. So to balance irons here 2 are there, here 1 is there. We have to multiply 2 here. So we get 2 FeS2. Alright, again 2 FeS2 2 FeS2 plus O2 gives rise to Fe2O3 plus SO2. So now irons are balanced on both the sides. Irons FeSO, irons here 2, there also 2. Sulfurs here 2, here 1. Sulfurs are not balanced. Here 4. Sorry, here 2, 2 into 2, 4. Sulfurs are 4. but their sulfurs are only 1. Sulfurs are not balanced. Then oxygens here only 2. Their oxygens 5. There is no difference in oxygens. So irons are balanced, but sulfurs and oxygens are balanced. Now we will balance sulfur. Here 4 are there, here only 1 is there, so we multiply 4 here. Then our equation becomes 2Fe plus 2 plus O2 gives rise to Fe2O3 plus we have 4, so there also we need 4. That's why we write 4 SO2. Now if you check irons, sulfurs and oxygens, irons are 2 balanced already. Sulfurs are 4. Sulfurs are also balanced. But if you check oxygens, here we have only 2, but there we have here 3 plus, this is 8, 4 plus 8, 3 plus 8, 11 we have. So 11. So what should be multiplied here to oxygen 2 so that we get 11? Because it is an odd number 11, by multiplying something to 2, we do not get 11. So what we do here, we multiply 11 by 2. So we write it as 2FeS2 plus 11 by 2O2. So then what happens? 11 by 2 into 2 will become 11. So we multiply 11 by 2. We can do that. We can write like this. 11 by 2 also we can multiply. So we get here 11 by 2 O2 gives rise to Fe2O3 plus 4SO2. This is what the balanced equation. But still if you want to eliminate this 11 by 2 and you want everywhere balanced, because here by 2 is there, so that every equation in every compound in the equation you can multiply by 2. Means what? To eliminate this by 2, everywhere we multiply 2. Then this becomes 4FeS2 plus this one will become 11O2 now. 11O2 plus this becomes 2Fe2O3. Everywhere we are multiplying 2. This is 4 no, so after multiplying 2 it becomes 8SO2. Only the difference, everywhere we multiplied 2 to it. So that 11O2 become 11 by 2, O2 become 11O2. Now if you check here, iron, sulfur and oxygen, irons we have 4. You can check here 4, here also 4, and then sulfurs here 4 2 is 8, here also 8 is 8, so 8, and oxygens 11 2 is 22 here, and there also if you check 2 3 is 6, 8 2 is 16, 6 plus 16 22. So oxygens are also balanced. So this is what one more example of balance in chemical equations. Hope you understood this also. Now by these examples, hope you understood how to balance the equations. Now to test you, I give you one question. You have to try it and answer in the comment section. Whether you will get it correct or not, I will check. Question is given like this: Al plus BO2 is given as Cal2O3. So this A, B, C are numericals. What number should be the values of A, B, C? What is A? What is B? What is C? So that this equation will be balanced. What should be the value of A? What should be the value of B? What should be the value of C? So that this equation is balanced. This is your question. If you have written this question correct, that means you understood this concept. Comment this answer in the comment section. I hope this video is helpful to you. Subscribe the channel and share it to your friends who understand this topic better. Thank you.